Hello and welcome back to Astrocapture, your podcast about astrophotography. I'm your host, Stefan, and today we're diving into a topic that's truly reshaping how we photograph the stars, artificial intelligence. Now, I know what some of you might be thinking. AI, isn't that taking the human out of this equation? That's not real astrophotography, or that's faking it. These are valid points, and we'll definitely explore them. But the reality is, AI is already here, and it's becoming a must-have of the astrophotographer's toolkit. It's not about replacing us, but about empowering us to overcome all challenges and reveal the universe in ways we never thought possible. So first, let's get the definition of AI out of the way. At their core, artificial intelligence and algorithms are deeply intertwined, with AI often manifesting as highly complex and adaptive algorithm. Think of an algorithm as a precise set of instructions for solving a problem, like a recipe. AI, then, is a sophisticated chef who not only follows a recipe, but can also learn to adjust ingredients, experiment with new techniques, and even create entirely new dishes based on past experiences and feedback. So, while all AI relies on algorithms to function, from the simple rules governing an automated telescope to the intricate neural networks distinguishing noise from celestial details, AI elevates algorithm beyond mere instruction following into the realm of learning, reasoning, and problem solving, enabling them to tackle challenges far beyond the scope of traditional programming. Think about the sheer amount of data we deal with. A single night of imaging can generate a staggering amount of information. AI helps us make sense of it all, from the initial planning of our shot to the final breathtaking image. It's a revolution happening in our field, and today we're going to walk through the entire astrophotography workflow and see exactly where and how AI is making its mark. We'll cover the tools you can use, the best ways to integrate them, and the all-important ethical question that come with this new technology. So grab a drink, get comfortable, and let's explore the future of astrophotography together. Before we go any further, you will find in the show notes a link to Astrocapture website where you can find examples of prompt you can use, as well as an infographic giving you a visual summary of this episode. And let's go to our first part, the Smart Planner, AI in equipment setup, planning, and target selection. Every great astrophoto begins long before the telescope even comes out of its case. It starts with planning. And let's be honest, planning can be one of the most challenging parts of the hobby. What's the weather going to be like? Where's the darkest sky? What object should I even shoot tonight? Traditionally, this involves juggling multiple websites, interpreting complex weather charts, and a fair bit of guesswork. But AI is changing the game. First up, let's talk about the weather. Astrophotography is incredibly sensitive to atmospheric conditions. We're not just worried about clouds. We need to know about seeing, stability of the atmosphere, and transparency. This is where AI-powered weather apps are becoming a kind of secret weapon. Tools like Uranus or Xasteria are designed specifically for us. They don't just give you a generic forecast. They use models to analyze huge amounts of weather data to predict cloud cover, seeing, and even dew point, often centered around midnight when we are most active. This means we get personalized recommendation for the best night to go out. But a word of caution. These AI models learn from historical data. This makes them great for predicting typical conditions, but they can struggle with forecasting rare or extreme weather events, what some call gray swan events. So, while AI is fantastic for planning, it's still wise to use your own judgment, especially when it comes to protecting your gear from a freak storm. And we're just at the beginning. New AI specialized in weather forecasts are already available and I hope soon to the general public. Beyond weather, AI is also helping us find those pristine dark sky sites. We all know light pollution is the enemy. AI-enhanced light pollution maps, like lightpollutionmap.app, use satellite data to show us exactly where the darkest skies are. They use metrics like the Bortle scale to help us find the perfect spot to set up. Now, once you got your site and a clear night, what do you point your telescope at? This is another area where AI is making things incredibly personal and accessible. In the past, you might look at the book or a forum for ideas, but those are often one-size-fits-all solution. Now we have AI-powered courses and assistants, some even funded by NASA, that give you custom target recommendations. These tools look at your specific equipment, your location, and the time of year to suggest objects that are actually achievable for you. It's like having a personal mentor on demand, which is fantastic for new customers and seasoned imagers alike. For example, you can use Gemini AI to help you with the choice of your camera for your telescope, taking into account the pixel scale and scene condition to get the perfect match. It can also assess the power consumption of your setup to select the best battery for your mobile astrophotography setup. Last but not least, AI can help you to select targets based on your equipment, type of filters, location to get the best possible targets for your imaging. So now let's go to our second part, the automated assistant AI in image acquisition. Okay, so we plan our session, we're out under the stars, and the telescope is set up. Now it's time to capture those photons. This is the acquisition phase, and AI is here to make it more precise and automated than ever before. The foundation of modern astrophotography is automation. Motorized mounts that track the stars, software-assisted polar alignment, these things have been game changers. A key part of it is plate solving, where your system takes a quick picture of the sky, compares it to a star map, and automatically centers your target. No more squinting through a tiny finder scope. While this core automation isn't strictly AI, it's a bedrock that makes AI so effective later on. The quality of your raw data is everything. If you feed an AI bad data, you'll get bad results. So this precision at the acquisition stage is absolutely critical. And this is where we see the rise of smart telescopes like the ZWO Star or the Varonis Vespera. These are fully integrated, app-controlled systems that do almost everything for you. They sleuth a target, start imaging, and even live stack the images in real time right on your phone or tablet. And yes, they're starting to embed AI directly into their apps for things like automatic denoising and sharpening. This is a huge step in making astrophotography more accessible to everyone. For those of us with more traditional setups, AI is also revolutionizing guiding and focusing. To get those long exposure with point stars, you need to auto-guide. This involves using a second small camera to lock onto a star and send tiny correction to the mount to counteract any drift or mechanical errors. But new AI-driven approaches are making this even better. Instead of just reacting to a star's movement, some advanced systems analyze the guide star's history to predict and correct errors before they happen. There's also emerging work on using AI for adaptive optics, making real-time adjustment to compensate for atmospheric turbulences, the very thing that makes stars twinkle. This is like moving from a reactive system to a truly predictive one, pushing us towards even sharper images. And let's not forget focus. Temperature drops during a long night can cause your focus to shift. Traditionally, you'll have to stop imaging and refocusing on the bright star. But new technologies like Sharp Lock are using AI for real-time autofocus. It continuously analyzes the shape of guide stars to make tiny, imperceptible adjustments to the focuser while you're imaging. This ensures your focus is critically sharp from the first frame to the last. It's a complete game changer for long imaging sessions. Coming right up after the break, our third part, the digital darkroom artist AI in post-processing. So we've planned our shot, we've acquired our data, and now we head inside to the digital darkroom. This is post-processing, and it's arguably where AI has had the most visible and transformative impact. This is where we take a stack of raw images and turn them into a work of art. The first step is stacking, combining multiple exposure to reduce noise and enhance the faint details. Software like Deep Sky Stacker and PixInsight are the mainstays here. And while their core function is mathematical, AI is being integrated to make them smarter. AI algorithms can now evaluate the quality of each individual frame, rejecting the blurry ones and intelligently weighting the best one to produce a cleaner final stack. But again, the golden rules applies. Garbage in, garbage out. The quality of your input data is paramount for AI to work its magic. This is why calibration frames are so important, your darks, flats, and bias frames. They remove noise and optical imperfection, giving the AI a clean slate to work with. Never skip your calibration. Now, for the really exciting stuff, let's talk noise reduction. High ISOs and long exposure create digital noise. Older tools could reduce noise, but often at the cost of smearing out fine details. This is where AI-powered tools like Noise Exterminator from RC Astro and Topaz Denoise AI are a revolution. They use deep learning models that have been trained on thousands of images to understand the difference between noise and actual celestial detail. The result? They can eliminate noise while actually preserving and sometimes even enhancing the details in a nebula or a galaxy. The same principle applies to sharpening or deconvolution. This process reverses the blur caused by your optics or the atmosphere. AI tools like Blur Exterminator and Thea AI are incredibly smart at this. They can analyze the image, figure out the specific type of blur in different areas, and correct for it without sharpening the noise. This is how you get these incredible, crisp, detailed, final images. One of the most important things to look for when choosing this tool is whether they are trained specifically on astronomical images. A generic AI photo editor might see a nebula and try to make it look like a cloud it saw in a landscape photo, introducing fake details or artifacts. This is a huge risk. Tools like the RC Astro plugins or Nebunoise are built on neural networks trained with real astro images, including data from Hubble and the James Webb Space Telescope. This is what ensures the details they enhance are authentic and true to the light you captured. Finally, AI is transforming two of the most tedious parts of the processing, managing stars and removing gradients. Light pollution often creates an ugly, uneven background glow color gradient. Tools like Rexpert use AI to automatically detect and remove those gradients, saving hours of frustrating manual work. And star removal tools like Star Exterminator or StarNet++ are simply magical. With a single click, they can remove all the stars from your image, leaving you with just the nebula or galaxy. This allows you to process a deep sky object and the stars completely independently, giving you incredible creative control before you combine them back together at the end. It's a workflow that just wasn't practical for most people before AI. And this is the time for our last and final segment, the human in the loop, ethics, and the future. So we've seen how AI can be a powerful partner in every step of your astrophotography journey. It helps us plan better, acquire images with more precision, and process them to a level of quality that was once out of reach for many. But with its great power comes great responsibility. We need to have an honest conversation about ethics. It's crucial to understand the difference between AI-enhanced and generative AI. The tools we've been talking about, Noise Exterminator, Blur Exterminator, are AI enhancers. They work on real data, but you captured with a telescope. They refine what's already there. Generative AI, like Midjourney or SOA, is completely different. It creates entirely synthetic images from a text prompt. These images might look like astrophotos, but they involve no telescope, no photons, no connection to the actual universe. There's a huge authenticity divide here. While generative AI is an amazing technology, it threatens to devalue the skill, dedication, and genuine experience of capturing real light from the cosmos. This is why transparency is key. When we use AI tools to process our images, we should be open about it, especially when submitting to competition or for scientific purposes. We need to avoid overprocessing and always compare our final image back to the original data to make sure we haven't invented details that weren't there. This is about maintaining both our artistic integrity and scientific accuracy. In conclusion, the best approach seems to be an hybrid one. Let AI handle the tedious technical tasks like noise reduction or gradient removal, freeing up our time and mental energy to focus on the creative decision that makes the image uniquely ours. AI is the assistant, not the artist. We retain creative control. So, what does the future hold? It's incredibly exciting. We're going to see AI get even more integrated into our hardware with smarter telescopes and cameras that have dedicated AI processors. We'll see AI continue to push the boundaries of scientific discovery, helping us search for exoplanets and even analyze data in the search for extraterrestrial intelligence. AI is not a fad, it's a fundamental shift in how we interact with astronomical data. It's democratizing the hobby, making it more accessible to newcomers, while also providing powerful new capabilities for seasoned experts. By embracing these tools thoughtfully and ethically, we can continue to push the boundaries of what's possible, sharing the beauty and wonder of the universe with more people than ever before. Well, that's all the time we have for today on Astrocapture. I hope this journey into the world of AI has been as inspiring for you as it has been for me. As always, you can find links to the documents we discuss in the show notes. Join us in 2 weeks as we explore furthermore our fascinating hobby. Until then, keep your eyes on the skies and clear skies to you, all of you. Thank you.